Ashutosh Kotwal, welcome to this show, and we are very pleased that you can join us. And for the others who are on the call, I'd like to introduce you to Ashutosh. And I recently read a book about his accomplishment, written by none other than his mother, who herself is a huge personality, and I can talk for hours about her, Mani Kotwal. But what I've read from the book, and also after following Ashutosh's work, Ashutosh has traveled quite a bit in India growing up in cities like Lucknow and Mumbai, and did his high school there. Then he came to University of Pennsylvania and did his engineering and also his economics from Wharton School, and then got interested in particle physics, went to Harvard and did his PhD there. And then over the years, now is professor at Duke, has done seminal work in the area of particle physics. And for us who are on this call, as biotechnology and biology experts, while it might seem very abstract, I think obviously the era of the merging of sciences, the biological sciences with the physical sciences, with the chemical sciences, etc., is where I think we are making new and novel discoveries. So I think that's a very exciting phase, and that's maybe something that we can try to see, to get Ashutosh's thoughts on that. So with that in mind, I think why don't we just Ashutosh say a few words, and then maybe we can ask you a few questions so that you can frame the conversations.
Sure. So maybe I'll pick up on your last theme. I think I know where you were headed with it. And it connects with my earlier comment on science education. And I also teach a large introductory physics course. This semester is electricity and magnetism, and previous semester it's mechanics. And my audience is in fact not engineers and not physics majors. They are in fact everybody else in the university.
Wow.
They are, medical student, pre-medical. In America, undergrad is pre-medical, it's not medical. Or neuroscience or economics, anybody wants to go to various other places, the rest of the university. But there are many curricula in the rest of the university which requires physics. And I've always asked those graduate schools, medical school and others, why in a curriculum which is completely dominated by chemistry and biology and things like this for pre-med students or other people, do you require 1 year of physics, right? So it sort of leads to the science education question. And the answer you get invariably from doctors or people on the medical board. Duke has a huge medical school, so I can talk to a lot of people there. And other fields also is science is not about just knowing the facts of that science. That's the general misconception, that science means you know these equations or you know those numbers and you know how to compute from X to Y to Z, and that's what you know. It's much more than that, and that is why the students I am teaching don't want to be in the class at all, because it's not their cup of tea, and they've always known that in high school. Like biology was not my cup of tea, and I knew that in high school. But people up there believe that if you are in a job which will require you to think, which is very different from knowing. Knowing is one thing and thinking is another. Thinking means that you know certain logics or certain facts, but in various situations, there are some implications of that, some logical implications. And, people will say things that make sense because you can see the logic. And people will say things that don't make sense because you can find out that the logic is flawed. Right? And there's a lot of this going around. So it's kind of socially relevant in a big way, I think, these days. Where people, if they were able to realize that what this person, this politician or somebody is saying, they're quoting some fact, but the logic from that is not correct. And who is thinking and realizing that, you made from A to B to C and, the flaw is in B. That statement is actually not logically correct. And therefore, your conclusion is misleading, usually driven by some agenda designed to mislead. That's what I conclude most of the time. The kind of education that science, not fact-based, but logic-based can provide can help you realize, I think this person is making sense, I think that person is not making sense, and this is why. Right? So when we call a goal to have an educated audience, an educated workforce, huge aspect of it is knowing the trade, knowing the skill set that are relevant for the job. But 5% of it should also be, can you think beyond your skill set in some situation that you haven't been exposed to, but you have some rationale, you have some ability to create a rationale, you have some ability to articulate the rationale, and then you can have a discussion. Here's my thinking, what's your thinking? And people spout all this stuff about democracy coming to an end and this, that. Okay, a lot of stuff on the airwaves about this kind of stuff. But in the end, if you go back to Socrates, whatever, democracy thrives when people can discuss. And you have to have a legitimate, logical debate. And the real issue right now is people are all afraid of a counter opinion. They don't want to listen to anybody who has an opposite opinion. I don't get it why, because they don't want to be proven wrong or something. I don't know. So this creates all these echo chambers on one side and the other, and they all talk to themselves, and the other gang talk to themselves, and then the two gangs hate each other, and then elections are swinging left versus right versus left because the center has been lost. And that's because nobody wants to talk with the other party, say, what's your real reasoning for this? You must have an argument. I'd like to hear your argument, then you can hear my argument, and we can talk like reasonable people and figure something out. Maybe we can disagree at the end, but at least I heard out what your thinking was. And this is part of what science teaches us. What's the rationale behind here? So let me stop here, but you can see.
Clearly that's on the top of your mind. Yeah. So why don't we ask folks to see if they have any questions to start with. You can ask anything.
Yeah, go ahead. Ask me a nasty question.
So maybe I'll get started while other people maybe are thinking. So Ashutosh, one of the questions that I had for you was, I know you've done a lot of work in the area of particle physics and all of that, right? And so I think where I like to see from biology. Biology is very, very complex. And I have a friend of mine who's an astronomer, and he teaches astronomy in UPenn, and he talks about the stars, and you're talking about particle physics. At some point, the lowest common denominator of everything is physics, I think, in my opinion, or maybe even quantum physics, right, to a certain extent. So how do you think, have you thought about how quantum physics and the physics that you do relates to biology?
Yes. So I'll give you a couple of answers. One is that I'm glad when somebody says physics is at the bottom of everything. I personally would say almost. What is at the bottom of physics is ultimately math, because math is the accurate expression of logic. That's what math is. And underlying everything is logic, including physics. I would then extend that to say, what is quantum? There's a logic behind it. And it seems nature obeys that logic. And in the end, that same logic must underlie the molecules in a biological system or a chain of molecules, or what forces DNA feels when it unzips and zips back, or how proteins stick to each other. In the end, it's all atomic and molecular interactions. So the physical logic has to be there. In fact, I'll quickly say this. We probably won't have time to, maybe a separate session. Last year, somebody in Duke Medicine heard my particle physics talk, and I was giving a lot of those talks. And they said, well, we have issues in medicine that we are using for 200 years that haven't been figured out fundamentally. And no, research is so clinical and so patient-centric, and the funding is all directed towards results within a few years, that deep questions never get answered because to some extent they never get funded. So we want to bring you into our group as a physicist, and because you guys talk about answering questions over 10-year horizons, to see if we can make biological systems a subject of physics experiments, so literally recording data, analyzing data, doing video recordings of it, analyzing with numerical equations, this, that. So I'm actually trying to contribute big time into that. It could become one of my major enterprises to take some interesting bio question, which has medical implications, and see what's the physics underlying it. For example, why is this protein reaction work this way? Seems like a major mystery. It must be molecular stuff. It must be quantum mechanical, electric magnetic fields interacting with electrons, protons. Down there in the end, what else is it, right? We're all made of electrons, protons, and electric magnetic fields. So let's ask the question that way and see if we can turn into a physics experiment. So indeed, I
Yeah,
think the answer to your question is yes. Um,
yeah. And I can tell you that
yeah,
Virender here has done a lot of work on cryo-EM, which is looking at not at the electron level, but maybe Virender, maybe you can talk about your work or maybe a question from you.
Yeah, something like which you are talking. So even like since my graduation, so I always see like physics has a theoretical part which can be proved using experiments. In biology, I always miss this part that we don't have theoretical biology that can be like put out and that can be then tested using experiments. How
yes,
how can biologists come up with something like a statement? Like I have seen like physicists publish papers where they just like claim that this is the statement which can be tested further.
yes,
For for biology, how we can come up with something like that that can be further tested the way like you are mentioning that physics could answer that uh, down the line.
yes. So physics has a bit of a leg up because if you write down basic laws of electricity, magnetism, electrons, and so on, quantum mechanical laws of all of these, which in the end, when we test in a physics experiment, we try to have a controlled experiment where the object of the experiment, or subject of the experiment, is designed to be as simple as possible so that you can access that relevant rule. Right? If you want to make a test of how the electron interacts with electric field, 100 years ago, some geniuses figured out you can literally isolate one electron. So think very hard how to do it. Then put that electron in a magnetic field, figure out how you can make an experiment that will detect a single electron, right? So that requires some brains. And so somebody like Millikan did a one electron experiment in 1932. Back then, there was barely any technology. So how do you do it? In biology, you simply cannot remove that simplicity aspect because the biological system is by definition complex. I mean, all of its biological implications arise from its complexity. The specificity of the molecule interacting with that molecule is simply because of the very complicated shape of this molecule and the other molecule have to fit together. Otherwise, they won't interact that way. So all of biology emerges from complexity, which is naturally contrary to the physics logic of simplifying to the building blocks, right? You cannot simplify here to the building blocks because you will kill the biological molecule. So that's why it's hard. So I wouldn't say there is a flaw in the field. It's just much harder to do fundamental
Yeah.
things.
So,
Having
so
said this, I will quickly finish my answer.
yeah, yeah,
That the growing field called computational biology, where people are saying, let's take the atomic level equations of electrons, protons, electron orbitals, all the stuff we learn in chemistry, work very hard at a software implementation of it, which is sufficiently powerful, coupled with essentially a supercomputer, where you can compute from atomic and molecular physics 1,000 atom molecule or 10,000 atom molecule. So this is actually happening. And they want to go to dynamics. So they want to do this computation at the level of every nanosecond. Every nanosecond, you want to compute. So it's a massive amount of computation. And their goal, I just heard from a scientist, they want to get to evolving the molecular dynamics of two big molecules for, did he say 10 microseconds? They think that's the typical reaction rate. 1/10 microseconds is some typical reaction. I think I got the number right. I can't remember. So if you start at a nanosecond level, which is the action happening at the fundamental level, you have to do that reaction 10 million times. So you have to interact 100 or whatever, 1,000 molecules with 1,000 molecules or 1,000 atoms with 1,000 atoms 10 million times. So it's a massive calculation, but all done at the fundamental physics level. This is where you're getting at. So it's actually happening as computing is growing and people are figuring out how to do very complicated many body calculations, which is an unsolved problem in physics, fundamentally, many body physics. And the answer appears to be mostly numerical. We just numerically compute on a huge computer.
Yeah.
So
Yeah.
you might get exactly what you want. 10 years from now, people would say, this reaction is expected to happen this way. Now go measure it. So let's get there.
Wow. Wow. No, I think this, and Virendra, that a very insightful question that you asked. How does the biologist hypothesize on something that doesn't exist today, right? And predict that this, based on the observations that we have right now, what could happen? Good. I mean, I think we can. This topic itself can be a whole whole meeting. But why don't we see if Shruti or Priyanka or Chirag have any questions?
So I had one question, which is not biological or something, which is just a general curiosity. I have two questions actually. One is the effects of chanting. So, like in one of the podcasts, I was listening that, when you chant, suppose a Rudram or something, your neurologically you become sound, or you attain a peace of mind. So does it generate any particles like God particles or something which kind of influences your mind to be calm? And when you go to certain places like temples, it gives you good vibes versus some haunted place which is known to be horrific. So does it have any particle physical, like as I told, like God particles or whatever. So does it have any effects on your psychological ability? Like, why is it happening? That why, I mean, that's what I wanted to know.
I'll tell you, I have some exposure these days. There are brilliant people like Roger Penrose and many others who have thought a lot about, personally, I think human brain is somehow probably the most powerful thing in the universe. Bigger, more than supernovae or galactic centers or something. Because within a very short time, we have now developed the ability to destroy an entire planet. Right? So I wonder sometimes, why are we in such a rush to go to the moon on Mars? Are we looking for one more planet to destroy? And so I'll have a lot of talk about AI also about it. Having said all this, we have no clue how the intelligence emerges in the brain. So, I'm starting to, in the context of my other biology work, we're starting to look at C. elegans, which is an extremely simple worm, right? You all know it's got 300 some neurons or something, and yet it appears to be pretty smart. It can react to vibrations and light and anesthesia and whatnot. So how do 300 neurons by themselves create a reactive system already? So, and then we have 100 billion neurons. So you can imagine, and each of those neurons is connecting to 10,000 other neurons. So this entire complex of 10 billion things, each connecting to 10,000 others, is an unimaginable number of connections which has consciousness emerging from it. There is some logics out there which are difficult to prove, and a lot of people object, that the notion of free will somehow violates the principles of physics. Principles of physics are all cause and effect. So A causes B, B causes C, and everything evolves because the previous state evolves to the next state by the rules of quantum mechanics or anything. But free will appears to be the ability of the brain to literally create a thought out of nothing, right? And if you believe in free will, you wonder, is it beyond physics or is it within physics? Now, Penrose has made an interesting postulate that in quantum mechanics, there is the unsolved logic of the collapse of the wave function. If you've heard that statement, it takes a long time to understand what they're talking about. But it means there is an intrinsic lack of knowledge in the quantum object. You can't know everything about the quantum object. until you touch it in some way, and then it chooses one of its possible choices, right? And so Penrose is saying this quantum wave function collapse could somehow be the origin of free will, which means ultimately down there, the emergence of consciousness is related to some quantum mechanical state that the brain has. So particle physics is just a manifestation of quantum mechanics on individual particles. We're just studying one particle at a time and what its quantum behavior is. So it's not like those particles are present in the brain necessarily, but the same principles that govern the evolution of the particles we study are influencing the neurons and the the chemicals that transmit in the synapse, all that stuff, and action potential. All in the end, somewhere down there, this is some quantum mechanical system, maybe. So quantum biology is emerging as a potential explanation for at least some things. Can you directly see the manifestation of quantum mechanics in biological systems? We have no clue what the brain does. How does music calm us down or some pleasant thought make us calm? It's an impossible question to answer because I don't even know what thought is. I don't know if anybody knows what thought is. It's some circuitry in the brain goes into some pattern and we call it thought. So clearly, music induces signals in the ear and those feed into the brain. So if I try to make a mechanistic model of the brain, I can imagine influencing the currents and voltages on the various neurons. Somehow we call it thought, but I think nobody really knows. So
wow, this is again another question that could require a whole session for discussion. And you brought up points like free will. My God, I've been reading Robert Sapolsky's book about this, and it's out of this world. But I don't want to digress. But let's see if there are more questions.
This is why I'm opposed to this craze of AI, whose fundamental goal, stated by Sam Altman on the cover of magazines to create super intelligence, in the end, it seems to be purposefully directed towards removing free will from humans. I sense that is the actual agenda. And we can barely understand intelligence. We barely have any intelligence. I doubt that we actually need super intelligence. And most of all, I doubt that we don't need free will to be destroyed. So I'm actually opposed to this kind of AI. We have to treasure the one thing that we have, which is free will.
Yes. Priyanka,
I have a question, Narendra sir, and thank you so much for organizing this event, first of all. And it's been very insightful, Ashutosh sir. And I have a question, which is a very general question, I think, for any immigrant who is living in States. So I was curious to hear your journey as a physicist, moving from India to States, and what kept you going and motivated through the transition. Another part is have you ever felt that your ethnicity was an obstacle, or has it given you a diverse perspective in your work? Thanks. Looking forward to you hearing your thoughts.
My answer is probably not what you expect. My answer is, for the most part of my life, in the beginning, I didn't actually care. I didn't care if my ethnicity was an obstacle. I didn't care that some people didn't understand my accent. I didn't care that some people couldn't pronounce my name. I think people probably figured out soon enough that I didn't care. So they asked me, can I call you this? Can I call you that? Most people are polite, so they would say, can you say it again? Did I get it right? And I would say, yeah, close enough. And this was over and over again. Can you spell your first name, please? Is it like this? Is it like that? And I was thinking, oh, you are willing to make the effort to get my name right. Good for you. I'll help you. And if you don't want to make the effort to get my name right, I don't care. So I have seen many people change their name. I have seen people shorten their name.
Mm-hmm.
I don't know what they think. Maybe it makes it easier for the others. So maybe that makes it easier to get accepted or something like this. And my reaction to all of that was, why should I care? I pronounce your name, you can pronounce my name,
Mm-hmm.
or don't. Free will. You can do whatever you want, I'll do whatever I want. And this is America. After all, we are in America where everybody can do what they want. So what's the point of coming to America?
Mm-hmm.
Everybody in the world wants to come to America. You go to Europe and you take an Uber, and the Uber driver says, "Oh, you're from America. I would like to go there someday." And nobody says this about going to Germany or France or
Mm-hmm.
so. So there is something about that freedom of choice, and I think I used it to the fullest by saying, "This is me and my name, and if you can't understand my accent, well, I'm understanding your accent. It's different from mine."
Mm-hmm.
So, and sometimes I would have to say things twice. Okay, I say things twice. And if somebody was friendly, they would say, "Could you say that again?"
Mm-hmm.
And if somebody's not friendly, they would not bother, and then I wouldn't bother.
Well,
And
I'll interrupt. Ashutosh,
and
I'll interrupt.
that got me where I am, so it worked.
Yeah.
Yeah, I'll interrupt and specifically ask you a question that Priyanka, and to follow up on Priyanka's question is, I know you must have had a lot of mentors and people who have played a role in your life. And what is, I think one of the things we talk about in this group is the importance of mentors in careers, right? So maybe you can
Mm-hmm.
talk a few qualities of your mentors that made a difference in your life.
Very big impact. This is sort of related, Priyanka, to your question.
Mm-hmm.
I hope it is still true, but it was definitely true 42 years ago when I came. The one thing that your mentors or the people that you want to become your mentors, what they notice, they will look past your name and your ethnicity and this and that and your accent, and they will look past everything. And those are the people that you automatically find as your mentors. And what are they looking for? They are looking for your passion and dedication for your work and the fact that you really believe in doing a good job. That
Mm-hmm.
whatever job you have chosen or you have been given or whatever it is, your top priority is to do it as best as you can, achieve your own level of excellence, right? Not some excellence that they are looking for, but some excellence that you are looking for in yourself. In other words, are you doing your best?
Mm-hmm.
What worked for me was whoever noticed that I was doing my best somehow became my mentor at some level, at a high level or a low level. And there was a physics professor who I ran into accidentally. I was looking for a summer job in engineering, and nobody there somehow had any funding for me. So eventually, one person told me, "I have a collaborator in physics. We work on some circuits together. Maybe he has money for you. You should go there." So I knocked on a bunch of doors. Notice that opportunity doesn't come to you. You just look around until somebody says, "Yeah, come on in, I'll talk to you. I have a job, I have some money. Let me see if you can do it." First thing he asked me, "Do you know programming?" I said, "Sorry, I don't know programming." He said, "Oh, okay, that's fine. Somebody told me that you're willing to work hard, so I'll look for another job." This professor eventually gave me 3 summer jobs, one after the other, and finally said, "Why are you doing engineering?" I said, "Sounds cool." And he said, "I'll show you something cooler. You should become a physicist." I said, "But my friends are telling me I should go to Wall Street. I have a Wharton degree and they're all going to make lots of money. And they think I'm a smart kid, so I can make even more money." And he said, "Don't waste your talent on Wall Street. You should become a physicist." And then I said, "But I have a huge fear of talking with people. I am completely frightened of stage fright or something." And he said, "Don't worry, 50% of the world has stage fright." So I said, "Yeah, I'm in that 50%. So I don't see myself ever becoming a professor." And he said, "Don't worry. As long as you really do your physics as good as you're doing, it will work out." I think in the message in the end I got was, of course, looking for mentors is a talent in itself. But to a large extent, if you're really doing a good job, and you have to do a little extra effort to make sure that people can see that you're doing a good job. So you can't be in a closet doing a good job and nobody ever finds out. So you have to make that extra effort to make sure that people are finding out that you are doing a good job. The right person will show up and say, I notice you're doing a fantastic job here. I have another assignment that you might be interested in. I have a higher level thing, more, maybe it will develop your talents further. I'd like to see if you can do this or that. So to a certain extent, America is America because some people in the right place literally believe in a meritocracy. When that gets wiped out, I really start to worry. That's the downfall of any institution or any country. But at least up to now, and this is what I've said in India too, if some people in India in the right places start believing in a meritocracy, then there is no stopping. The country can rise, people can rise to whatever level. And so trust the system, look around for who believes in meritocracy, just show them your good work. The prerequisite is that you care about your own good work. And when you see you care about your own good work, people start caring.
Nice.
People care about people who care about their work. It's almost like that.
Yeah.
Thank you so much for answering it. Thank you.
Yeah. No, I would, Priyanka, if you have a chance, I'll put the information about the book that talks about Ashutosh's career. It's a very, very important book to read. And I think
I have a question, if I can interrupt.
One second, one minute.
Yeah.
Let me just finish this.
Yeah.
The book, I think we'll put that book on the group site.
Yeah.
I think it's a very important. All the questions that you asked
Excellent
related
book,
to.
yeah.
All the questions that you asked related to mentorship and his career are written in that book. So there's a lot of background that you will get.
Yeah.
Ujjwala Khare is my sister and also has known Ashutosh since
Hello.
decades.
I mean, your book was simply amazing. The English one, the one which was translated, I couldn't put it down. Your journey is remarkable. So I wanted to ask a question that has anyone found you that being a bright student, like you were a bright spark. So have you met any student who's a bright spark and has found you to be his mentor and trying to take your path? So you may have noticed like how someone noticed you, that you were hardworking, you had that extra zest for work. So have you noticed anyone in your journey?
Yes. I have, for 20 years, I've been mentoring both undergrads and grads.
Okay.
Duke is a good place, so a lot of bright kids come through. And
Okay.
some of them I noticed through coursework, but I also have a lot of research projects. I have 4 different research projects, each involving 3 or 4 undergraduates each.
Wow.
There's a
Fantastic.
forum to advertise, and it's self-selecting. And when I click that, it's an interesting principle I follow. I say you're accepted, and I accept 20 people. And 7 or 8 of them will ask me, hey, I saw that you accepted me, but you never reached out to me. So I'm reaching out to you, and then I won't respond. And then they come knocking on the door. Hey, I saw that you had accepted. Then I sent you an email. I never got an answer. So I'm actually coming to your office. You were out of town or something. So now I know that this student is not just looking for a bullet on the resume to say that.
Yes.
But they're actually willing to not give up and find me no matter what it takes. Then I say, now let's start talking. So the 20 initially comes down to 5.
Okay.
And
Fantastic.
then out of the 5, I see, somebody is a computer science major, math major, this, that. So I find the appropriate piece of my research which they would like. And then actually from the 5, 3 of them will stick it out for 2 years.
Okay.
Then I know that this is the kind of person I want to recommend to grad school or whatever they want to do, right? They want a recommendation for IBM Consulting or Apple job or
Yes, yes.
Harvard or MIT. And invariably, from that crowd, the few that I select are getting into the best grad schools. I mean, they're all going to Princeton, Harvard, MIT. Every year, I'm sending 2 or 3
Fantastic.
these places.
Okay,
And
Amazing.
thank
Very
you.
good.
Thank you.
Very,
Thank you so
very,
much.
very good
so,
question. So I'm going to pick on Chirag a little bit. Chirag, I don't know if you're available to talk.
Yes, sir. I'm available,
And
sir.
yeah,
Uh,
so Ashutosh, Chirag is one such student who has persistently communicated with me. I would say in a very nice way. Chirag doesn't leave me alone. So,
yeah,
any question you have, Chirag?
yes, sir. Yes, sir. I want to know means like what qualities and what means like with eagerness can we approach to means like to my supervisor or guide or something means like what different work means like we can make so that their attention can catch us.
yeah.
Any
So I'm,
approaches?
I'm going to say one thing that is a little bit outside your control. Everything I've been saying, your persistence, your commitment to your own excellence, which means, sometimes you're trying to solve some research issue or some software, whatever it is you do. In the evening, your friends will go for a movie and they'll say, but I really can't quit on this thing. Or you get up in the morning and it's on your mind and you say, I want to wake up right away and work on this thing that I couldn't solve last night. That kind of, I don't want to use the word workaholic, that has a negative connotation, but this commitment then becomes a priority, sort of a slight obsession of some sort, right? Not to the exclusion of other important things, but to the exclusion of less important things. It becomes an obsession. So you have to balance it. All these things you can do. One thing that is outside your control is the mentors that you find, who finds you, which advisor you end up with, a little bit outside your control. Uh, there is an aspect of luck. Uh, Now, people say things which are cliches, right? You make your own luck, and all these cliches are out there, but that's not quite true. You can do all the other things with persistence and dedication, all this, but there's a couple of things I will say. This physics advisor, at the end of my 3rd year, I said, okay, I'm going to choose physics. Fine, I'm convinced. I sort of asked the question you mentioned. There's a point of advisor, and I have to choose a topic, and then I have to find a person who will become my PhD advisor. And this professor smiled and said, I remember the day we were in an elevator. He said, you'll make 2 extremely important decisions in your life. The choice of advisor will be the second most important decision you'll ever make. I said, my God, is that important? But I was curious. What's the most important decision I will make? Tell me that first. He smiled and said, the person you decide to marry. So we all had a good laugh. What do you say about that? It is partly luck. And in that sense, choice of advisor, okay, jokes apart, it was true. You ask around, I don't know which phase you are in at the moment, but one thing you can do in the sense of diligence is you talk to other students, you use the network of information about what different people are like, what are the experiences of their earlier students. Do your homework the best you can. But then in the end, we live in a world of people, and people can be their own people, and you do your best with whichever advisor you end up with. And don't forget the fact that unlike marriage, your advisor will not be with you forever, right? A few years from now, you will move on and you will find a second advisor or supervisor or somewhere else. And there are other, life goes on. So don't worry too much. The last thing I will add is if you've done everything you can do, the rest works out.
Yeah, that is so true, Ashutosh. I think we don't. I love to say that the universe conspires to make things happen to you once you try with the right earnest and genuine approaches, right? So let's see.
Do not ever dwell on something that you perceive as bad luck.
Yeah.
Never take that negative attitude about, oh, I did everything I could and I still got unlucky.
Yeah. Let me see if there are any further questions on this call. Otherwise, what I'll ask Shruti to do is to do the rapid fire part. But before that, any final questions, Ashutosh? Okay. Hearing none, Shruti, why don't you take over? And Ashutosh, this is sort of like fun exercise, and Shruti does it so well. And so, yeah, there you go.
Okay. So it's like a quick question, and you can answer in few words or a word, whatever you feel comfortable with. So life in USA versus India, which did you enjoy the most in your lifetime?
Most. It's been so many more years here, so I would have to say here.
Okay.
But I will say it's an unfair question. Unfair question.
Okay. Fine. What's the most rewarding part of your field?
The fact that you are trying to figure out how somebody, I believe in a high entity, it's a belief, it doesn't have science behind it, but somebody figured out how to engineer a set of rules by which all creation has happened, including us. And every time you get a tiny slice of it, this little rule does something very amazing, and the universe works this way because that rule is there. Every time you discover something like this, you feel like you're accessing the mind of that entity. It's an amazing feeling. You don't get it very often, but it's worth struggling for that feeling.
Awesome. What is the common misconception a layman has about theoretical physics that you would like to address?
I've heard the argument that it's all abstract. And at some point, I start to think, define abstract. And people say, I feel this and I feel that, and that is real. But because I cannot see an electron, it's abstract. And then I ask the question, tell me what you mean by feeling. And then the conversation starts to end because nobody can define their own thought, what it means, or consciousness, what it means, and what feeling means, and what anything. So I said, well, isn't that all abstract too? Your love you feel for your spouse or child or something, how do you define that? Isn't that all abstract too? So we are all made of abstractions. And theoretical physics is trying to attach a certain logic to things that are actually part of the universe. It's the most real thing there is.
It's so true.
I don't even know what reality means. I dreamed last night in color that I was sitting on a sinking ship or something, and it was extremely real, and I woke up in a panic, and I thought it was real. And then I realized it was just a dream. Tell me that it wasn't real.
So if you could have any superpower right now, what that would be?
I have superpower. If I can understand even 0.1% of the universe working, I think I am super powerful. Good enough for me.
Awesome.
If everybody could have that, I think everybody would be super happy.
And maybe just a last question that I have is, what is the future of your work? Like the most interesting thing that we can aspire for next 5 to 10 years, which is very exciting.
5 to 10 years. Hard to predict what nature has in store. So in particle physics or in general of my part of physics, you're trying to understand what nature's mystery is hiding. And there is no obligation from nature to reveal it to you. All we can do is try under every rock, right? So it's the excitement of the search. I would not say that it's the fact that there is no prediction that the mystery will be revealed in 10 years. You simply have to be excited about the best way to do the search. So if we can figure out what kind of particles dark matter is made of, or if we can figure out, you mentioning Higgs boson earlier, that if the Higgs boson is actually made up of some constituents, like the atom was made up of protons and electrons, at some point in history, we didn't know that. For a very long time, we didn't know the atom was made up of things. We didn't know the proton was made up of things for a long time. Now we do. So if the Higgs boson is made up of things, that would be quite revolutionary. If dark matter is particles that we can actually detect, that would be quite revolutionary. So those are our goals and ambitions, not predictions of what will happen.
Wonderful. So, yeah, so I think that's it. Thank you very much, Ashutosh. This has been such a
Good
enlightening
questions.
discussion. Yeah, I must say, all the questions, have evoked a lot of subsequent questions that might come up. So we might actually, in a couple of months, maybe 6 months or so later on, if people are interested, dive into these further questions with you later. So again,
Sounds
thank
good.
you everyone, and
Well,
thank you
thank you,
everyone. Thank you everyone for calling in. And Virendra, thank you for all the work that you do to make these shows happen and put them up on YouTube so that they're available for people to get inspired by. So thank you everyone.
Thank
Good
you.
night.
Thank you so much. Yeah.
Thank you, Uji, and hope to see
Okay,
you.
bye. Yeah, lovely. I want to hear something more about how astronomy and
Wait,
physics. That part we'll do another one. Yeah.
We'll do another one. Yes.
Yeah.
So thank you everyone. We can
Okay.
stop recording.